Hello, Ines. I can see you. Can you hear me?
Hello. Hello.
All right. Okay. Okay. I believe a bit of coughing, yes, still.
Yeah, I'm just sick in general. I have a headache.
Right. 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 Let's still do it, but I guess you don't have to talk so much. Just see what's in front of you. Okay.
Yeah, maybe not 1.5 hours. Maybe just like 45
Mm, give it a try.
minutes.
Fine. Swing. I think we're ready. Wait, what? Oh yeah, we're ready.
Are we doing okay?
Yep.
Oh, without him? Why?
Sorry, testing. Yes, we're doing. Okay, I'm sorry. You're saying?
Without.
You're saying? Sorry, you're saying?
We're not doing without Jonty.
We're not doing. I'm sorry. What? We're not doing what?
We are doing okay without Jonty.
Hey, John T, I think is just correct to contact him. Then his mother say that he's basically concussed lah.
Huh?
Right, he concussed. I mean, he cannot even wake up. That's what his mother say.
As in, he's
Right,
actually
so
concussed or just sleeping?
he is sleeping and he cannot be woken up.
Okay, I thought he was
And
actually.
not gonna. Yeah. No, he's fine. Yeah, not gonna worry about that. Right, no urgency for now. We have been studying a lot of the OChem, and although I really want to finish all the theory, but today let's look at the questions, and you'll see the fruits of your study lah. Maybe that's also a good thing lah. Then we'll finish up after this. Has your class started OChem?
No, I haven't gone to
Right.
school. So I don't.
I see. Right. Okay. Never mind that then. Okay. So you are seeing this, right? You don't have to take notes, just see my screen, and then also make it that you can annotate, right? But again, if you have trouble saying things, then don't say too much, right? Okay. Now you see the screen. Just confirm that you can annotate, please.
Yep.
Right, cool. All right. You can also clear. Okay, wonderful. So you use blue, I guess. I'll use red. Okay. Now, you don't know much beyond what I told you, and I was saying that those are the essence, right? Let's see whether that's true or not. For this question, it is obviously OChem, even though they don't say it, right? The word here is isomer. Whether you remember isomer or not, well, what do you think about this question?
I don't know what isomers are.
Right. So back then I was asking you, and John P, right? Oh, there you go. Okay, right. So visual revision very quickly, Anish. This is 5Cs, and then this is an isomer of that, and then this is an isomer of this. So these are all isomers of each other. That's it. Any questions?
Where are you?
Are you looking at my screen? Oh, I'm sorry. That was my mistake. Sorry. I think that was my mistake. I share it in a way that you cannot see. I'm sorry. Now you can see. Right. Can you see?
Yes.
Okay. Sorry. Yeah. Oh, no, that's not good. Right. Okay, done. Wait. Should be like this. Okay, right. Okay. So visual revision. This is 5Cs. So 12 H's if you count. Then this guy also 5C is an isomer of this. This guy also 5C is an isomer of this. So they are isomers of each other. All have 5Cs and all do have 12 H's. Back then you guys counted. Are we okay?
Okay.
Then go back to the question, which is okay. So like that, who are isomers of each other?
They're all the same.
They are, sorry, don't say the word the same. Huh? If they are the same, they are not isomers. Isomers are similar but not the same. What do you mean?
They're similar.
No. They are isomers, right? So let's start from 1 to 2.
4 isn't similar.
Okay, let's start from 1 and 2 first. Right? So just to confirm, you think 1 and 2 are similar but not the same to each other?
Yes.
Looking at the number of C and number H, well, I won't be surprised. Now let's go to 3. So is 3 similar but not the same to 1 and 2?
It's the same as 2, actually.
So if it is the same as 2, is it similar to 2? Is it isomer to 2?
No.
Very good. Very good. Now 4. Same or similar or not?
No.
No, it is similar. That means I think it is an isomer. Why? Well, I mean 5Cs, 12 H's, so very happy with that. And more importantly, the structure cannot be 1 or 2. So the number of C and H is the same. The structure is different. Isomer. Can you accept that?
Yes.
I think this is a bit of a coincidence, but we did draw all these 3, which is what I showed you just now. Maybe that's why you have a recollection. Good luck. 1, 2, 4. Now 5.
Is this not the same as 2?
You're saying that it is same, not just similar. Could you figure out in your brain, by right, you should be drawing and sketching things that will make things easier, but could you just see it inside your mind? It's not, I'm not asking for it. I'm just, maybe you can.
Yeah, I think it's the same.
And you will be correct. And therefore, in this case, if we are both correct, then the answer will be 3. Just to confirm to you that 3 and 5 are indeed the same, this is what I do. Just count the main addresses, 1, 2, 3, 4. So this will be a side, correct? A side branch. So 1, 2, 3, 4, this is a side branch. Hey, this is clearly showing that 2 and 3 is the same, the side branch at 2, right? Okay, so this one, 1, 2, 3, 4. Side branch at 2. This clearly shows that 2, 3, 5 are the same. Got it? Will this be okay?
Yeah.
Right. So these are the foolproof method if you do it correctly, right? Good job, right? Okay, going. Let's move on to the next question. Would like to highlight that you seem to understand what's going on, right? As a bonus, a very good bonus, you seem to figure it out, right? Okay. Now, this one I will have to explain to you just one thing that I haven't told you, right? So, different vegetable oil and margarine, and then he goes through hydrogen, right? They are supposed to tell you already that margarine are alkanes, and vegetable oil can be sometimes alkenes, sometimes, not always, but it can be. You familiar with the names?
Yeah.
Alkenes are double bonds, and alkanes, well, don't have anything special, right? What's the connection between hydrogen and alkenes?
There is more hydrogen in alkanes
than alkenes. And in the reaction map, there's a reaction going from alkenes to alkanes. Can you picture it in your mind? I'm asking you not to see the Jamboard yet. Can you picture it? Is there such thing in your mind?
I know something, but I forgot what it's called.
Right, because our purpose is to make the reaction map permanent right now, not as in, I mean, now, not near the exam. Yeah, so I'm trying to reinforce it first before we actually look at the Jamboard. Don't worry, we'll be looking at it, or you can also look at your paper. Please don't first. I'm going to reinforce. The position of alkane is where in the reaction map? You tell me.
Alkane is top right.
Right, and alkene is?
Top left.
And then you have, bottom left, bottom right, and then you form a C, correct? Not a full circle, just a C, correct? Yeah, connecting all four. Okay. Then alkene going to alkane will have one arrow, and so happens there's an arrow in reverse also. Did you at least remember that?
Yes.
Then the only detail left to remember is, hey, what's the reaction going from alkene to alkene? But you already say there are less hydrogen in alkene, there are more hydrogen in alkane. So it must be hydrogenization, and which this question makes a lot of sense, therefore. Make sense? Correct? The question makes a lot of sense. Because they don't even ask you what's the reaction. You just have to, it makes sense. I guess I still can follow the question. Would that be okay?
Mm.
So when he say hydrogen, which is needed for hydrogenation, pass through 1 gram of sample, you tell me the sample will be vegetable oil or the sample will be margarine.
P and Q, C.
Thank you. Margarine. So you think that P is a margarine and Q is a margarine. Now you think carefully. That means you think R is not a margarine, right? You think R is not margarine, right? I just write it down first. Not margarine. Now, this one, again, I do have to tell you. So the vegetable oil is the one with which is alkene, double bonds. The margarine is the one without double bonds. That means only single bonds. And you are telling me this one more hydrogen and this one less hydrogen. And you would be correct. Okay. Now you tell me the vegetable oil, the P passes through hydrogen hydrogen passes through, hydrogen passes P, and then there is no more hydrogen, and you think P is margarine, which is here. You think this thing, it comes in contact with hydrogen, and the hydrogen will all be gone.
No, that doesn't make sense.
Why doesn't that make sense?
Because it's supposed to lose hydrogen, not gain hydrogen.
Yeah, or if you want it to turn, and which is it's very difficult to lose hydrogen, by the way. But more importantly, you cannot gain hydrogen, which is to say the hydrogen will not be gone. Fair enough, if it is a margarine. Then, would you like to change your answer?
Our answer would be just Q, but now there is no option like that. So,
all right, then let me point out one more thing. Yeah? For the margarine, because they keep asking about margarine. Yeah? For the margarine, I say more hydrogen. You'll be correct to say that. Is it possible for an alkane to absorb or link with more hydrogen?
yeah.
You look at the picture. Everything is visual, right? Look at the picture. So here's a very simple alkane, right? C5. These are all hydrogen. We just don't draw it, but we draw all the hands. You tell me how much more hydrogen can this take? All these hands are already hydrogen.
No more.
The variation isomer, how much more?
Oh, that's true. No, that's the same.
And just to be clear, this one?
Oh, yeah, also the same.
So even though we isomer stuff, the H will not change. It will be 12 also. And you're saying that it's maximum. I will agree with you. This guy already maximum. A margarine is already maximum hydrogen. Is it possible if Q is hydrogen, if Q is margarine, will the hydrogen be reduced?
No.
If R is margarine, does that make sense?
Yeah.
It's only R. Okay, Ken? So this is not just more H, it is maximum H. That is true. That will never change. That will never change. Would that be okay?
Yeah.
Okay, clear on drawing. Now, question 38. Hey, 39. Let's confirm that all of these are in the reaction map, but you don't see it. You kind of just try to remember. If you don't remember, it's fine. I'll show you anyway, right? So let's not answer the question first. Let's just prove that our reaction map is complete enough, right? Okay. Combustion. Have or not? Let me remind you of the shape. I purposely choose like this, and then we start with the C, correct? Okay. And then you have your back and forth reaction, blah, blah, blah. And then do you remember that there will be outer reactions, and then there will be an inside one. And then finally, this last one. This is the shape of reaction map. It's actually hopefully easy to remember. Usually. You say no combustion, you would be wrong. The combustion is the one inside law. Everything plus O2 becomes CO2 and H2O. Okay? At least vaguely remember that there's something in the middle, right? And then, you'll get better and better. Esterification, have or not?
Have.
Where?
In the final product.
Yeah, which is the one connecting acid, ethanoic acid here, and then ethanol here. Okay, it's there. Good. Fermentation of glucose. Have or not?
What's that?
Fermentation of glucose. I mean, is it in the reaction map or not?
Yes.
Where it is?
The big sugar one, I forgot where it is.
Make a guess lah. Make a guess. I mean, making a guess, there isn't too many options. At least make some guesses.
I think it's here.
You're absolutely correct. This is your glucose. You see sugar. Glucose means sugar. You ferment it and it becomes alcohol. That's the position. I mean, maybe you've heard about it. Fermenting something generally makes it alcohol. I guess that helps to remember what it is, right?
Yeah.
Good. Now, neutralization between hydrodilute hydrochloric acid and aqueous ammonia. Is it in this reaction?
I can't remember the reaction, so I'm gonna say no.
Yeah, and you will be correct. Something similar, but not this. Yeah. Here is carboxylic acid. Remember the COOH, right? And then you react with the base lah. In this case, I say NaOH, and that is a neutralization, but that's not equals ammonia and hydrochloric acid, obviously. So it is not in this reaction map. This is not an organic chem reaction, but it is a reaction that you're supposed to know. So good for you.
Yeah.
Okay. Any questions so far before we try to answer?
No.
Okay. Combustion, produce water or not? Oh, goodness me. That one a bit scary to me. So yes, there. You burn something with O2, you get CO2 and H2O, okay?
Yeah.
Now, when answering a question with not in MCQ, don't do this, right? Instead, do this. This might be easier for us. This means, yes, it is a product. Of course, that means it is not the answer, but still say, yes, it is a product. Okay? Don't say, yes, it is a product, then cross it. I personally find that confusing. If you don't, then you don't have to follow me. I will generally tend to look for 3 ticks and 1 cross, if you understand what I'm saying.
Yeah.
Now, esterification, produce water or not?
Yeah.
Yes, that's what gets ejected. Okay, 2 ticks, nice. Fermentation of glucose. The problem is, do you remember? Not complete reaction. Do you remember me saying that? It's not a complete reaction. They don't tell you.
Yeah.
So this is a question mark. Oh dear. Now, neutralization between acid and aqueous ammonia. Water or not?
I don't know.
Even though this is your weaker subject, weaker topic, but use whatever you have now. This is an acid, and this is aqueous ammonia is. I mean, the word neutralization means it is a base, right? It's a base, right? So NH4 OH, I'll tell you. So does this two produce water or not? Neutralization. What is a base? Oh, I'm sorry. What's an acid? H plus. What's aqueous ammonia? It turns out it has OH, right? So H plus OH becomes? H plus and OH minus becomes?
Ester.
Oh, wait, H plus and OH minus.
Becomes H2.
Yeah, so this one also a yes. The answer will be C, not because we know, we do not know, but everybody else is a tick. Okay. Why don't we know? We don't know the reaction. Will this be okay?
Yeah.
Now, you did 3 organic chem questions. You haven't done it in class. Do you think you know what's going on?
I hope so, since I haven't gone to school yet.
No. I mean, do you know what's going on in these 3 questions? Do you feel like you can follow them?
Yeah.
Good, that's what I'm aiming for. Now, last one, polymerization. We did not finish polymerization, okay? We did not. So I probably cannot even explain. I'll try, and if you don't understand, it's okay. We'll have to discuss this later on. Oh, goodness me. No, I probably cannot. No, I probably cannot for now. Okay. Now, let's look at section A. I'm sorry, it's an MCQ, so I'm going to skip the MCQ. Right. Oh, goodness me, that's so weird. Another MCQ. And they don't give you, oh, goodness me, I think they have a problem. They don't give you. Okay, never mind, never mind. I'm going to go down. Now, I'm going to section A. Section A is 50 marks short, and then section B will be 30 marks.
Hello,
Do you
hello.
have any, can you hear me?
Yeah, I got kicked. I just joined back. Hello.
Right. Can you see my screen then?
Yeah.
Okay. I'm not at the MCQ part. I'm at the other part. So paper 1, paper 2. Section A, 50 marks, short one. I mean, it's not that short, but the answers are short, right? The answers are short. And then the remaining 30 marks will be a longer one. Do you have any idea how your paper looks like?
I can check.
Feel free, check out the paper which is not MCQ and see how similar it is, I guess.
I'll check ethics.
Sure thing.
They're separate papers.
Tell me how it looks.
There's first paper 2. There's 2 sections, 70 marks.
I see. Okay.
And the first paper is
MCQ then.
30 marks of MCQ.
Right. Okay. So not very different lah from what I'm looking at here lah. The what you call the paper 2 here will be a total of 80 marks. Right. The MCQ will be a total of 40 marks. So I think your paper is just slightly longer. Okay. Let's finish this paper and then maybe we can look at your paper. Okay. Finish means just the OChem. Okay. Now, this OChem or not OChem, you think? OChem or not OChem?
Yeah.
This is OChem, you think? Sorry, you think? What do you see that this is OChem?
Actually, no, okay, no. I saw hydrogen.
Right.
I thought, okay.
Hydrogen, of course, got in OChem, but not all hydrogens are OChem. Yeah. Okay. Hydrogen is popular though, so I guess that keeps popping up, right? Good news or bad news, I don't know, but OChems are very clear one, and you'll see later they're quite long. OChem or not?
No.
I'll agree with you. pH, whatever, OChem or not?
No.
Acid, yeah. So although there are acids in OChem, but there are no, it's not here. And this one, right? OChem or not, you know what it is, right? Yeah, clearly, you know, OChem or not?
Yeah.
Yep. Now, you see the double bond immediately? right?
Yep.
They call this propene. Any surprises?
Okay.
Right. Then look at the first guy. The first guy is reaction lah. He asks you to calculate. They don't give you the reaction. What do you think based on your experience? Do I need to write down the reaction first? Or maybe not? If I could do it without the reaction, I should. What do you think? Or you can do something else entirely, like if you want to. But my point is, what do you think?
I feel like there's more involved.
You are absolutely correct. Calculation, especially see gram some more, this is almost certainly more than, and you're on point. You're on point. My question remains though. Do we do it without the reaction, if possible, or if there is no reaction, we have to write down the reaction first so that we can do it, or there's some other possible thinking out there. You are correct. I'm sorry, you're saying?
We have to do the swapping thing, the UV swapping thing.
That means you want the reaction, is what you're trying to say. Without the reaction, it is impossible to do a mole question. Yes or no?
No.
Sorry, means it's possible or it's impossible? Sorry, what?
Possible.
No, it's not.
Oh.
In fact, you need the exact reaction. You need the exact balance reaction to do any mole question. I mean, I'm going for 99% correct. This is 99% correct. There are simple questions of mole that does not need that simple one. Right? The normal one, like this one, definitely, and you don't have. Now you're reaching for UV look, right? You're reaching for UV. Now look at the reaction first. The mass of bromine liquid required to react. Okay, I'm going to draw the reaction map. I mean, think about it for a while. It's not very difficult to draw the structure at all, isn't it? Yeah, I finished drawing the structure already. Wouldn't you agree? Right?
Yeah.
Now, this is bromine react with propene. Now, which one are you referring to just now with the UV and everything? Which position?
UV reaction which caused bromine to be sucked in.
All right, you are mixing two things, and I want to clarify that. The UV one is here, and it is a complicated swapping reaction with not alkene with alkane. Okay, the swapping happens with alkane. Okay?
Yeah.
The bromine is where? The bromine is here with alkene. Because propene, double bond, and here's a bromine, and you don't need UV to do this at all, meaning this is easily done. I told you that UV is the indicator that it is harder to do. I mean, standing under sunlight is considered harder to do, I suppose, right? Yeah. So it's an easy one. That's your bromine with propene. That's the location. And just by this location, can you write down the reaction or not? If you could, that is very, very good. Would you please try? The reaction, yeah? The reaction. Ganesh, do you give it a try?
Yeah, sorry, I'm just really tired. I think that
we can end after this. But try this one. The reaction first. You need the reaction. So the reaction first, please.
Plus Br2.
Write down. I mean, I don't know. You just tell me and I'm going to write down for you. I'm sorry. What is it?
C3H6.
Plus
Br2.
Is that all for the left-hand side?
Yes.
Becomes what? Important.
C3H4Br2.
Okay, now let's be very clear about what happened. Double bond always break and then suddenly the Br slips in.
Yeah.
This is not a swapping with existing H. Do
Yeah.
you realize that it is not a swap? That's why we don't call it swapping. That's why it is not the UV one. The UV one is required to assist in the swapping. This is not a swap. This one is slipping in. We call it addition. Now, don't say C3H4, then C3.
H6.
Good. Br2 lah. Done. And the reaction, balance it.
It's balanced.
Wonderful. Now, 1 mark low. This is your 1 mark. I mean, I think better to write down the state symbol, but you still have to memorize that. So I guess we'll just leave it like that for now. I'm sorry. This is supposed to be liquid and liquid, but that's for us to memorize. Okay, 1 mark for you. Let's call it that way. The second mark will be the mole calculation. Now, what do we do with 1 gram of propene or whatever you want to start?
Mole equals to mass over MR.
So,
you find the MR first.
Right, which is 12 times 3 plus 6 times 1, right, which is 1 over 42, right? So 1 over 42 mole for the propene. And then what?
And then mole ratio. So
who is 1 over 42 again?
The mole of the bromine.
Right, also 1 over 42 mole. And what do we do with that?
We multiply by M.
Or Br, which is times 71 times 2. Why times 2?
142. So 142 divided by 42.
Yeah, and whatever that is, that will be correct.
Yeah.
Okay. Even though it's a simple mole, but it is something. It is something. It shows you that mole is in OChem, although not very complicated. And yeah, glad that you seem to be able to figure this out with my help, but you're not lost. Right? Okay. And then yeah. I'll see you tomorrow then. Okay.
Yeah. Thank you.
Good job for today. Bye bye.
Bye bye.